Hi, everyone, and welcome. My name is Cade and I manage our enterprise sales engineering team here at Fivetran. I work in our Denver office, and I've been with Fivetran for about 2.5 years. And today we're going to talk about the modern data stack and also how Fivetran fits into that modern data stack. So without further ado, we will get going here. And to understand the modern data stack, we need to start with the legacy ETL, kind of the old way of doing things. And legacy ETL really started and was centered around database limitations. And because of these slow transactional databases that require data to be transformed and shrunk down pre-load in order for it to fit, that required extensive setup and planning of your BI stack. So you had to know the questions that you wanted to ask of your data before that data even got to your BI team. So that required a lot of setup and a lot of planning. And if you didn't get all the data that you wanted, or if you pre-aggregated that data incorrectly, maybe you were missing some data, you had to come all the way back to the beginning, and that was a very long and drawn out process. Your BI team had to get back with your engineering team and rework all of those transformations and aggregations to make sure you had that data right. And finally, that leads into the last part of this process, which was ongoing maintenance, making all these changes, or when maybe a data changed in one of your sources, or the questions that you're asking of your data changed. That created very brittle pipelines that you had to manage on an ongoing basis. It wasn't just building out these pipelines one time. You had to continually keep adding to them and maintaining them. And again, it's a very arduous process, and it's a very time-consuming process for your team. Instead of actually gaining insight from their data, they're building these brittle pipelines just to get that data transform and shrunk down into your database so that you could actually extract it into classic BI tools that were actually really running on desktop computers, and you were extracting that data out in basically like a data mart to perform your analysis on that data. So continuing with some of the issues in here was created that we call the BI challenge. So you have an end user, let's say this is your CEO, and you deliver them some data that was, you modeled out this data, you got it right, and they're happy. They're able to actually get the question that they, get an answer to the question that they had. But what happens when they say, okay, this is great, what about this? That starts this whole process over again. So this is the basic flow from the end user. Let's say that is the CEO making that request through the legacy ETL workflow. And as you can imagine, with this many steps and parties involved, it was not the most streamlined and efficient process. So and a lot of the bottleneck here would end up with the engineering team and fitting this into their development cycles. This is a lot of tedious work, and instead of your analysts just being able to instantly be able to gain insight from your data, they can't do that because this actual access to the data that they have is very limited. So again, comes back to that whole planning, and the ROI on this was really delayed. Actually getting that data to your end users. So what changed? And what changed was really the addition of the cloud data warehouse. So starting in about 2012 with Redshift, they were really the first ones on the scene. And now with Redshift's newer version, the RS3, as well as obviously big players Snowflake and BigQuery, the cloud data warehouse has really allowed the landscape to change because of some of the huge benefits that it brings to the scene. So like I mentioned before, a lot of the limitations of the classic ETL process started with that database. So when you no longer have that database that's limiting you on your processing power or your storage, it really enables you to expand out what you're able to do with your data. So going into some of the benefits here of the cloud data warehouse, you have compute and storage. So first, the separation of compute and storage. Cloud data warehouses provide instantly scalable compute, and users can now provision additional nodes for on-demand query power without having to pay for permanent storage capacity. So you don't have to have one without the other. You can just get the storage on demand. And speaking of storage, storage is really cheap now. It costs about 2 cents to store a gigabyte of data, whereas even back in the 80s, that was hundreds of thousands of dollars. So, and that price just seems to keep going down and down and down. I believe a terabyte of data now is roughly about $20. So not free, but really just a drop in the bucket in terms of the historical perspective on how much it actually costs to store large amounts of data. And finally, as far as the compute and storage side, these cloud data warehouses are really fast. So we just published our latest blog post on the warehouse benchmark test just last week. So we won't get into that during our presentation today, but I highly recommend checking that out. It's this link right here. If you just go to fivetran.com/blog, you'll see that warehouse benchmark test. Next, and I can mention this with the compute and storage, but maintenance is really simple. You can actually maintain everything for a cloud data warehouse right in the web UI. You don't have to have a bunch of tuning and maintenance for these databases. They're really simple to maintain, and if you ever needed to add more compute or storage, it's a few clicks of the button and you're ready to go, and you can do that in almost no time. And then finally, supported data. Cloud data warehouses actually support structured and unstructured data. So you can be more flexible with the data that you're actually putting into that warehouse. So here we're just looking at a high-level overview of that legacy ETL versus the modern ELT paradigm. So that's where this modern data stack really comes into play with this ELT, flipping the L and the T in this process, which is really enabled by the cloud data warehouse here. So if we look at the old process, like we just walked through here, you have your different sources, you extract that data and transform that data down and pre-aggregate it before loading it into the database, which is then passed down to your BI tool. Whereas with the modern cloud data warehouse, you can do full schema replication of your data, load all of your raw underlying data into your cloud data warehouse without having to worry about trimming that data down or pre-modeling and aggregating it just so it'll fit. You can load it all into your cloud data warehouse, and then that way you can transform that data and model it within the warehouse and then pass that modeled data down to your BI tools where it can be analyzed and creating visualizations for your end users. So it's the big shift here from that legacy ETL to the modern ELT. So as part of the modern ELT, you have the modern data stack. So what is the modern data stack? And quite simply, it's made up of a few simple components. First, it's a data ingestion tool. Next, and which is sort of like the center of the modern data stack, I would say, is the cloud data warehouse. And then finally, a BI tool for visualizations. And some of the benefits of using a modern data stack are, like to call it best of breed. So instead of using just one tool that does all of these operations or some of these operations pretty good, you're using the best of breed with each of these tools. So you can use the best data ingestion tool, the best data warehouse, and the best BI tool that fits your needs. And each of them is focused on one part of this stack. It's it's almost like if you think about it like an assembly line or a line chef as at a restaurant. You don't have just one chef make everything. You have one chef focus on what they're great at, and that's kind of how I see the modern data stack. Is each one of these tools is focusing on just part of the stack that they really excel at and they are great at, and not trying to overextend themselves and be a BI tool and a data ingestion tool. Just allowing each of them to really excel at their piece of this stack. So let's dig into the actual pieces of it. And first is a data ingestion tool. So why would you use a data ingestion tool? And or really, what is the actual? Let's get into what the data ingestion tool is. So in the modern data stack, they're performing the E and the L from the extracting and the loading from your disparate data sources, which could be SaaS applications, databases, files, or events. And we'll dig into these a little bit with Fivetran here in a little bit as kind of the preferred part of the data ingestion tool in the modern data stack. But some of the benefits of using this tool are building ETL jobs and pipelines is time consuming and resource intensive. Like I was mentioning with the classic ETL paradigm, you not only have to build these data pipelines once, you have to maintain them over time. And that's a lot of difficult work for your data analysts and engineers. And a lot of times that's not work that they want to be doing. A cloud data ingestion tool will also have access to your data sources, pre-built connectors, so that you can just plug in, kind of plug and play with your integrations. These tools also can do incremental loads, so that the data that needs to be refreshed can be refreshed, and you constantly have that new data available to you for your downstream BI processes. And then maintenance, kind of going back into the building of these ETL pipelines. You don't have to maintain them on an ongoing basis, because that can be keep going back to these key terms, but it is really time consuming and expensive for your team. So next part of the cloud modern data stack, is the data warehouse. And obviously we've talked about this pretty extensively so far during this presentation, but one thing we haven't talked about, at least directly, was columnar databases. These cloud data warehouses are column stores, as opposed to kind of those classic databases that a lot of folks may have used, like an OLTP, row store databases that are great for lots and lots of incoming transactions, but not performant when it comes to analytical queries. And that's where these columnar databases really come into play and take a huge load off of the database, or add more performance to these databases as they're trying to do these more analytical queries that are, sums and averages across whole columns instead of just individual rows. We already touched on this one as well with the separation of compute and storage. Obviously driving down just the overall storage cost of this data. You can now load all of that raw data into your cloud data warehouse and not worry about missing any of it, or trimming that data down and not knowing, am I going to need this down the road? Is there going to be a use case for it? You don't have to ask those questions anymore. You can have that data already in your data warehouse and right at your fingertips, and don't fret about what questions tomorrow may ask, because if tomorrow does ask that question for that data, it's already there for you. And then finally, ease of use. I mentioned this with basically cloud data warehouses can be managed from the GUI, their web GUI. You don't have to have a DBA to optimize and work with all the nuts and bolts of these databases. You don't have to worry about query planning and dedicating resources to it. They basically take care of themselves, and they're so easy to add more resources as you need to. And then the last piece of the modern data stack are actually the data visualizations, and those are your BI tools. So with BI tools, you're ultimately empowering your organization. In the modern data stack, your analysts can be just that, analysts. They don't have to worry about going back to engineering and asking for these resources and for all this data. The data is already there and accessible for them, and they can start working with it. Then obviously one of the big outcomes of a BI tool or the data visualization capabilities, and something that obviously is going to play a key role in what you're looking for out of these tools. And then finally, modeling the data. There's lots of different options to just do, manual modeling of the data. I mentioned doing transformations within the data warehouse. And then also really common thing that's coming out are blocks, a commonplace actually within the BI space, or blocks, kind of basically pre-made queries that your analysts can already start working with your data. And not only is the data already accessible to them, a lot of the work's already done as far as gaining insight from the data that's been delivered to something like a cloud data warehouse. So that was an overview of the modern data stack, and I mentioned I was going to dig in a little bit to Fivetran and how Fivetran fits into that modern data stack. So what our goal is making data as simple and reliable as electricity. So if you kind of think back to, or if you just think about how electricity has made it into modern society, you can basically just plug in, and you don't have to worry about the infrastructure that goes with all the wiring and the central substations and everything like that that's required to actually deliver you electricity. You can plug right in and you're ready to go. And that's really what Fivetran is striving to do with data. We want to make data, again, like it says here, as simple and as reliable as electricity, so that analysts are enabled to analysts and engineers are actually enabled to start gaining insight from their data without having to go through that whole difficult process, worrying about the infrastructure, worrying about maintaining these pipelines and all the pieces that come into that legacy ETL paradigm. That's what Fivetran is really striving to do. And how we're doing this is, obviously Fivetran is a automated platform. So we take care of the E and the L for you, and we have over 150 pre-built connectors, so that we say it's built by engineers for analysts. So analysts, you don't have to, there's no coding involved, and for most connectors, you can be set up in less than 5 minutes, and that data is going to start flowing to your cloud data warehouse. And we do a full schema replication and full historical sync of your data, and then start doing incremental loads from there. So Fivetran is also resilient. We use an idempotent platform where if a failure occurs at any part in the process, Fivetran can recover from that point and continue to deliver your data in a clean and reliable fashion. That's ultimately what we're trying to do, again, is deliver you that usable data that's not only accurate, but in a format that you can just plug right into your queries in the cloud data warehouse or downstream in the BI tool. And then finally, Fivetran is cloud native. So I always like to frame this as Fivetran is the active partner in our relationship with our customers. So you can rely on us to update source connectors when API changes, or when there's a new way of actually loading data into data warehouses. That's on Fivetran to do, and to not only update our functionality, but find the best way of loading that data in the most efficient way, and loading that data into your data warehouse. So in comes the conversation of total cost of ownership. We kind of see ourselves as or when you could actually think about it is like we're basically becoming kind of experts in loading data into these data warehouses. So again, kind of bringing it back to that cloud native functionality and being the active partner in there. You set up your connectors one time. You give us that access, authorize the connection, choose what data you want to sync, and then it's on Fivetran from there to make sure that as APIs change, as new endpoints are added, as the data itself changes, we're capturing all of that for you so that you can be focused on gaining insight out of your data and not all the under the hood plumbing and infrastructure that goes into delivering that data for you. Kind of continuing on about some more specifics here with Fivetran. I mentioned full schema migration a couple times during the presentation. And I think that's really important, especially in the context of a modern data stack. When you have all of your underlying data and all that raw underlying data already in your cloud data warehouse, that's really what's empowering you to create efficiencies in these processes and ask all the questions that you possibly could from your data. And you also have to keep those schemas up to date. And that's where pipelines before can become really difficult to work with and really brittle. Whether it's a schema change that occurred because the source, you actually changed the data and the underlying source. So something like changing a column name or adding a new column, or if it's more on a functional level, like I already mentioned, API changes. Fivetran handles both of that. Obviously, we talked about the API changes and how Fivetran's the active partner in these in the relationship with our customers, but also the automatic schema migration. Fivetran handles that automatically as well. In the past, these are stuff that would break your pipelines, but now Fivetran rolls with those changes. We add columns when new columns are added. We update data types when the type changes on the source side. And if a column is deleted, we actually don't delete that column. We keep that column in the data warehouses, basically being net additive. So moving on from that, some of these other points here, I already mentioned being idempotent, automated recovery from a point of failure, and that happens automatically. If a sync fails at any part in the process, Fivetran will pick up where it left off. We do that by having a stateful process, and kind of as part of that process, we do our syncs in micro batches. It is again a batched process, but we don't try to load all of your data in one fell swoop. Sorry, to your data warehouse. We want to be a good steward to not only your source systems by being cognizant of how many API calls we're using or how much load we might be putting on a database. And we do that by running smaller queries on a database and taking into account automatically handling rate limiting and throttling on source APIs. And then on the database side, for our ongoing replication, we do log-based replication. So we don't actually have to read data directly from source tables. We're just reading from those logging systems. And then one last piece I'll touch on here are cloud functions. So these cloud functions, whether they're AWS Lambda, Google Cloud Functions, or Azure Functions, they're a great extension of the Fivetran platform. So these are used in situations where maybe you have a private API that you've developed and there's really no way for Fivetran to build a native connector for that. Or maybe it's just a source that we don't have a native connector for yet. You can extend the functionality of Fivetran by using these cloud functions. They're very powerful tools that you're basically just giving Fivetran access to invoke that function, and then it's passing back a payload of data to Fivetran to process and load into your cloud data warehouse. So it's really doing about 60 to 70% of the work for you. It's scheduling out that job. It's just, you just need to point us towards where we're needing to get that data from, and Fivetran's handling the rest. So that's it for my presentation. Thank you all for your time, and If you're interested in Fivetran and want to learn more about what we have going on in our piece in the modern data stack, please stop by our booth. But thank you all again for the time.